Scientists claim that time is nothing more than an illusion created in your mind. In reality, everything happens in the present moment, in a single instant. Now we will show you why the James Webb Telescope, beyond any doubt, can prove this thesis. Stay with us, get comfortable, as we delve into entirely new dimensions of the universe. The illusion of space-time. Physicists describe time as a fundamental concept or dimension whose function is to allow us to perceive changes in motion. Space-time is the union of space and time into a single four-dimensional structure, where space encompasses length, width, and depth, housing matter and changing over time due to certain forces. Scientists envision space-time as a kind of web or structure in which large objects such as stars, galaxies, and even planets leave distinct traces. In Albert Einstein's general theory of relativity, he wrote about how space-time bends due to the presence of matter and energy, how this curvature creates the force of gravity, and how entire galaxies come into motion. But both the special and general theories of relativity tell us even more about time. Like most other forces in the universe, time is a quantity that behaves relative to the observer. If you change your location or if there are specific distances between you and another person or an event you are involved in, your perception of time changes. This already shows that the physics of time is anything but linear, even if your clocks tell you otherwise. Strictly speaking, the clock always moves at a constant rate. Nevertheless, you can also feel that your perception of the clock's hand can stretch, slow down, or accelerate. The same applies to the vast structures of the cosmos. Where space-time becomes extremely curved, time passes differently. Near a supermassive black hole, time flows much slower than in other places. Time in everyday life. In the physical sense, time is connected to our everyday system of time, but there is an important distinction that we would like to illustrate with a small scenario. The divisions of time into hours, seconds, days, and even years are auxiliary means for organizing our daily lives. However, from a physical mathematical perspective, these units are not entirely accurate. No day is exactly 24 hours, and a year doesn't have exactly 365 days. We can only approximately define the essence of time, an exact definition is still lacking. Perhaps for the sole reason that these units do not exist in reality. Let's return to our small experiment. Imagine for a moment that a mass amnesia event has occurred worldwide. No one remembers what time is. In an instant, all clocks have stopped. Do you think people would still be able to organize their incredibly complex daily lives? It's unlikely. There would be complete chaos, and people would initially struggle to orient themselves. Even if all clocks stopped, people simply forgot about time, the physical measurement of time wouldn't have stopped. To understand this measurement, you can imagine that with the cessation of the physical measurement of time, all forces of motion and changes in matter would come to a halt. No planet would orbit around a star, no galaxy would spin through space. You would stop breathing, and your body would cease to function. This stagnation would correspond to the death of the universe and the end of life. At this moment, what some researchers claim, that time is an illusion existing only in our minds, might seem like outright madness. And as they say, the James Webb Telescope has provided evidence of this. So, what did James Webb discover? When the new space telescope transmitted its first images in July 2022, the entire world held its breath. The image of the deep field, unprecedented in sharpness and depth, revealed the existence of several galaxies that existed 300 million years after the Big Bang. These incredibly ancient galaxies shouldn't have existed according to the previous model of the Big Bang. According to past assumptions, it should have taken billions of years for galaxies to form and move through the universe in the form of spiral disks or radiant spheres. What does this discovery mean now, and how does it relate to the nature of time? Do telescopes show us the past? A telescope is a device that captures light rays and combines them to form an image. Telescopes also have the ability to capture light rays from vast distances. Even in your mind, there's something similar to a telescope. You can easily look to the horizon or to the end of a room. Your eyes also capture light rays and assemble them into an image. According to physics, there comes a time when the light from the horizon or from the far end of space reaches your eyes. According to previous cosmological models, light travels through space at a very high speed, so when we capture light from a distant object with a telescope, we theoretically see light that was emitted a long time ago. In the case of these extremely ancient galaxies, the light theoretically traveled for billions of years before reaching the mirrors of the James Webb Telescope. We, as humans, tend to think within limited dimensions. Time and space have a beginning and an end. The concept of infinity, on the other hand, is complex for many people. Scientists have calculated the history of the origin of our universe based on known physics values. Factors such as the idea that things have a beginning and an end, as well as the notion of a universe linearly expanding in space, played a role. Eventually, a scenario emerged in which it is quite possible that there was an initial event that we now know as the Big Bang. At that time, the creation exploded from a tiny point into the presumed space and has been expanding in that space ever since. Researchers were then calculating values for things like which gases were involved, what temperatures were present, and in what form subatomic particles existed, from the moment molecules first appeared to the emergence of matter, stars, galaxies, and so on. These processes followed a timeline, and according to it, 200 million years should have passed after the initial event, not in any way leading to stationary and fully formed galaxies that produced more stars than today's galaxies in addition. Since these discoveries are known, scientists are forced to admit that something is amiss with the previous understanding of the beginning of our cosmos. Currently, there are three approaches. Either the Big Bang happened much earlier than previously thought, or the formation of matter and objects in the early cosmos occurred in a completely different manner than scientists had imagined. Or perhaps there was no Big Bang at all. Since the Big Bang is equated with the beginning of time, this would also imply that the beginning of time and time itself may not exist. Scientists, as mentioned earlier, still think in very linear patterns. There was a starting point up to a certain point in time. From that moment, particles, molecules, and matter evolved at specific rates, determined based on time and today's observations and measurements. After 200 million years from the Big Bang, complete galaxies couldn't have existed. This assertion, based on a temporal measure, a starting point, and the passage of 200 million years, is now in question. Changes occurred during this period of time, but previous assumptions about these movements and energies cannot be correct. Now the key question arises: what is incorrect? For some scientists, the answer to this question can only be this: our understanding of the universe, where time passes linearly, is incorrect. Until now, scientists believe that the initial point of light emission was in a point distant in time and space, and the final point of light observation is in the present. In between them, light apparently traveled billions of years to reach us, and in that intermediate space over billions of years, events related to energy and changes in matter occurred. This effect is what we know as space-time. Light wandered through space, thus marking the passage of time. But it is precisely this assumption that may be fundamentally incorrect. All calculations regarding the cosmos and its expanding evolution may be flawed, which explains why modern models of the Big Bang are incompatible with the contemporary observations made by James Webb. Time and quantum mechanics. The physics of subatomic particles shows how strange not only the nature of time is but also matter. In quantum mechanics and related physical disciplines, scientists study the building blocks of the universe, or the elementary forces that give rise to the universe. Quantum mechanics has revealed that physical quantities such as energy, momentum, and even time can take discrete values rather than being continuous. This is called quantization, and in practice, it means that time is not a continuous or linear force but is constructed from tiny particles that you can think of as super small pixels. Time quanta function like a network, imperceptible to us in our everyday lives. They shape our perception of time and, consequently, events within space. However, the influence of quantum time fades, much like the influence of quantum matter, at the boundary of the uncertainty principle and the uncertainty of time and energy. This boundary describes the transition into a dimension where measurement accuracy no longer exists. Various quantum models have shown that our visible world is constructed from this dimension of uncertainty in every moment. The universe is a projection of the moment. If we view the world and the cosmos from this perspective, there is always only an eternal present, with no continuous flow of time happening beyond our brains. Here, the disciplines of physics intersect with other fields such as philosophy, brain research, or the views of Eastern schools of wisdom and religion. In these disciplines, the passage of time is described as a construct that occurs solely within the mind. While philosophy still debates the potential harm of such a perception of the world, the teachings of Eastern wisdom take a more straightforward approach. There, the dimensions of space and time outside of us are described as an illusion. Imagine for a moment that what you see may not necessarily exist outside of you as you see it. You can only perceive an image that your brain assembles from the rays of light entering your eyes. Whether this is reality or whether your brain filters out certain dimensions remains an open question. In Eastern religions, the mind is liberated from its perceptual barriers through meditation. Then, the gaze must become free to see the true nature of the world. It is nonlinear, with no beginning or end, and represents an eternal cycle of renewal and departure, with the fundamental structure of life always remaining. What does this mean for our universe? When you combine these new perspectives, it becomes much more likely that in the coming years, researchers will find evidence that we indeed live in a multiverse, or that the theory of the universe as a giant, highly mutable projection will receive a boost in development. Researchers may also discover that time is even more flexible and relative than previously thought. For your everyday life, this could mean that you'll learn to stretch and alter time according to your circumstances. You won't be living by external time frames anymore. Instead, you'll be creating your own time as it suits you. This, of course, means that time as a sequence of events or as an illusion, which we might also want to experience, truly exists. It's just that the nature of time is quite different from what was believed before. We hope you enjoyed this journey into the world of space-time and its entirely new possibilities. What are your thoughts on time now, and can you imagine life without clocks?